Morning everyone and welcome back. Hope you have all stayed safe and well, and your families too, during the extended Easter break. We now need to really crack on with the syllabus to make sure that we are not behind. There are a number of you who have not yet completed the work from before half term. You need to do that as a matter of urgency. There are still 4 people in this set that have not done the test on the previous topic. Please get that sorted as a matter of urgency. There are also quite a number of you who have yet to respond to my feedback on the Formula of Ionic Compounds worksheets 1 and 2. Okay, for a lot of you it's putting in subscripts. Can you please make sure you sort that out and resubmit the work as soon as possible? Now the focus for today's lesson is going to be looking at molecular substances, substances that contain covalent bonds. A molecule is a group of atoms that's held together using covalent bonds. And we should all know already that a covalent bond is a shared pair of electrons. Remember, one shared pair is a single bond, but you can also have 2 shared pairs, a double bond, and even 3 shared pairs, known as a triple bond. Now, many non-metals exist as molecules, as do the vast majority of compounds that contain only non-metals. So non-metallic elements that we're talking about here are things like oxygen, chlorine, nitrogen, key examples we need to know, and compounds, things like ammonia, which is NH3, hydrogen chloride, HCl, water, H2O, methane, CH4. All of these contain only non-metals and so contain covalent bonding. Now, molecular substances consist of very small molecules, tiny molecules, and the molecules are not bonded to one another. The atoms are held together within that molecule by strong covalent bonds. There are some forces between molecules, and these are called intermolecular forces. Okay, they are only weak forces, and it's these forces that are broken during a change of state, so during melting and boiling. Now, molecular compounds have a low melting point and boiling point because it's easy to break these intermolecular forces. The covalent bonds are not broken during melting or boiling. So just to illustrate, in ice, there's lots of water molecules neatly arranged, as you'd expect for a solid. In water, there are water molecules still arranged fairly randomly, but not particularly randomly, but quite close together. Notice that molecules are still intact, even though we've melted the ice to make water. There are still H2O molecules there. And again, when we go to gaseous water, steam, you can see the water molecules in this diagram are still intact. What's happened is they have spread apart because the intermolecular forces have been broken. Okay, this is very important to remember. Why do small molecules, or simple molecules, have low boiling points? Because of weak intermolecular forces between the molecules. There's a general rule of thumb that we'll talk about later when we do crude oil fractional distillation in year 11, but generally the bigger the molecule, the bigger the boiling point. So something like methane, which is CH4, is a gas, but octane, which is one of the main constituents of petrol, C8H18, is much bigger. It's therefore got a higher boiling point and melting point, and it is actually a liquid. Now, molecules also are electrically neutral. There are no free electrons to conduct electricity. Now, this is a bit nodding on to a later topic, really, but just for your information at this stage, we ought to know that molecular substances can have two formulas. There's the molecular formula, which is the one we normally use. That's the number of atoms that are shown in the normal standard chemical formula. So H2O consists of 2 hydrogens, 1 oxygen. The other one is the empirical formula. That's the simplest ratio. And we'll talk more, as I said, about that later. But something like glucose has the molecular formula C6H12O6. But then if you cancel that down to the simplest numbers possible, its empirical formula is CH2O. Notice we don't write C1 or O1, we just leave C as meaning 1 carbon and O as meaning 1 oxygen. We'll see this also when we look at alkenes in a later topic. All alkenes, things like ethene, C2H4, propene, C3H6, have the empirical formula CH2. Now, this is work that you should have done at the end of last term, and if you haven't done that yet, you urgently need to catch that up. Drawing molecules. You need to be able to draw dot and cross diagrams. They're called dot and cross diagrams or stick diagrams. Okay, you should have done the worksheet already. I hope you have. If you haven't, then get on with it, please, and make sure it's completed, well, as soon as possible. So, just to get you thinking and back onto that sort of idea, what I want you to do is work out how many covalent bonds each of the following atoms will form. Okay, please pause the video now, and then I will go through the answers in a second. Okay, so chlorine has 7 electrons in its outer shell. So it needs to gain 1 more to give it a noble gas electron structure. So that means chlorine forms 1 covalent bond. Fluorine, group 7 as well. So that needs 1 electron to become like a noble gas in terms of electron structure. So 1 covalent bond. Oxygen, group 6, 2 more electrons needed, so it forms 2 covalent bonds. Same with sulfur, that's also group 6. Nitrogen, group 5, so 3 electrons need to be added to give it a noble gas electron structure with 8 electrons in the outer shell. So nitrogen forms 3 covalent bonds. Carbon is in group 4, so it doesn't take a genius to work out that that needs 4 more electrons for it to have 8 in its outer shell. So carbon forms 4 covalent bonds. Hydrogen only has 1 electron. It needs 1 more to have the same electron arrangement as helium, 2 electrons. So hydrogen forms 1 covalent bond. So, as I mentioned earlier, a single bond is 1 shared pair, double bond 2 shared pairs, triple bond 3 shared pairs. And what I want you to do, if you haven't done so already, is complete that handout. Please do not forget that there is a drag and drop exercise on my Hot Potatoes website that you can use to help you. Okay, the diagrams on that drag and drop exercise are the ones that you must know for GCSE. Okay, there's a couple of extras in there. If you want to have a try at those, as 1 or 2 people have already done so, then please try them. If you don't want to do them, then that's absolutely fine, but please make sure you can get to grips with the ones that are essential for GCSE. Okay, now notice for these dot and cross diagrams, you do not have to put the inner electrons. You only need to draw the outer shells. Okay, So I'll check in with you on Wednesday. But please make sure you are up to date with all the work by Wednesday.